Good day, everyone, and welcome to class. It's my pleasure to see you, and I'm happy to know you are following the lectures. One thing that I've told us in one of our initial videos was that we are committed to making you understand that mathematics can be understood, can be loved, and can be solved without problem and without any ambiguity. Thank you very much. Yeah, if you remember, in our last class we were discussing indices, and we've been able to establish the fact that there are some laws that govern indices, and I could remember vividly we talked about multiplicative law. Today we'll go to the second law of indices, which is the division law. Laws of indices. So today we said we are starting with division law. Okay. So what does division law says? Division law says that when you have indices of common base, you pick one of the base and you subtract the powers. Let's see. So take for instance, if you have in general, the law says that when you have x raised to power a divided by x raised to power b, then since the bases are the same, s and s, so we pick one of the base, which is x, we subtract the powers a minus b. This is the solution. Now let's take one or two examples and see this solution. Alright, so we have x raised to power 4 divided by x raised to power 2. Using the law of indices, that will be, we pick one of the base, we subtract the powers. So x, 4 minus 2, of course we know it should be 2. So that is the answer. And if we are not using this law of indices, let's see how we would have solved it. Without law of indices, it would have been, of course, we know x raised to power 4 would have been x times x times x times x. And likewise, x raised to power 2 would have been x times x. Now, dividing this, so x raised to power 4 divided by x raised to power 2 will give us x times x times x times x divided by x times x. By the time we divide, this x will cancel this x will cancel this x, then our answer remains x raised to power 2, which is the same as what we got. As I said in the last class, that it's always very important, very good, and very fast to use the law of indices rather than using the normal division or multiplication procedure, because there are some instances where we can have the repetition of a particular number over a large number, like 50, like 60, and like 40. So let's take one more example and see. So we have y raised to power 12 divided by y raised to power 4. So this will be y raised to power 12 minus 4. Then this will give us y raised to power, this will give us y raised to power of 8. So likewise, let's confirm what we just did using the normal procedure. That will be y times y times y times y times y times y times y, 1, 2, 3, 4, 5, 6, 7 times y times y times y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times y times y. Multiply by divide by y in 4 times. Y times y times y times y. This y cancel this y, this y cancel this y, this y cancel this y, this y cancel this y. Now let's see the number of y that we have left. We have 1, 2, 3, 4, 5, 6, 7, 8. So our answer is going to be y raised to power of 8. You can see that we got the same answer, but the procedure are different. One is faster, one takes more time, and I leave you to decide. That I want you to know that it will not always be easy to use this other method when you have instances where your y is raised to power of 50, 60, 70, as I've always said. Thank you very much. The next law after the division law is the power law. Power law. This law says that when you have a number that is raised to a power and you into a bracket, then another is raised to another power outside the bracket. That is what this law is applicable to. Now let's see what we are saying. What I'm saying is, in general, the law says when you have x raised to power a into the bracket of y, then this will give us x raised to the power of a y. Now, let's see some examples of this law. Let's take 2 examples as well. So when you have x raised to power 2 into 3, so this will give us x raised to power 2 times 3. Then you have x raised to power of 6. This law is product power law. Product power law. This product power law says when you have the multiplication of 2 numbers in a bracket, and now they have power outside. So it means the 2 numbers which are products that are in the bracket are having the powers. So they share the same power, and that is why they come into one bracket. So let's see what we are saying. So in general, this law says AB raised to the power of n is the same thing as A raised to the power of m, B raised to the power of n. That is product power law. Now let's take some examples under that. Yeah, before I continue, I want you to know that we are just paraphrasing these laws so that by the time we need them, we can easily remember that we've talked about them, because we are still going to take real indices questions. So that by the time we begin to solve real indices questions, by the time we begin to apply these laws, we can easily remember that we have talked about the law. Now, let's quickly see an example of this. When you have 2a raised to the power of 2, this now will give you 2 raised to the power of 2, a raised to the power of 2, as we have seen here. This bracket indicates that both 2 and a are the holds this power. These 2 has power, a also has power. That is why we kept the 2 in the bracket. That is the implication of the bracket that is there. And so, in order to solve it, we need to let 2 have its own portion of the power, then a has its own power. So, by the time we multiply this, 2 multiplied by 2 squared is 2 times 2, which gives us 4. Then you have a squared. This is the answer. So let's quickly take another example before we go to the next law. So 3 raised to power b cubed. This will give us 3 cubed, then b cubed. This will give us 27b cubed. Good. Now let's go to the next law. The next law is the power zero index law. Zero index law. Zero index law. This law is telling us that any number raised to the power of 0 will always equal to 1. Any number raised to the power of 0 will always equal to 1. So, let's see. In general, the law says that when you have x raised to the power of 0, it will always give you 1. So when you have b raised to the power of 0 will give you 1. Likewise, 2 raised to the power of 0 will give you 1. So any number that is raised to the power of 0 will always equal to 1. As you can see, after 0 law, the next law we are going to talk about is negative index law. So this negative index law is telling us that when a number is raised to the power of a negative number, so it's going to be 1 over that number. So this is my own code. My own code is a raised to the power minus 1. This particular minus will become 1 over on its own. Then the a will be under, raised to the power of whatever the number of that minus. Okay, so what of when we have a raised to the power minus 2? Don't forget I told you that this negative itself becomes 1 over. That's this negative. Then you are left with a and square. So a and square. So what about we have 3 raised to the power minus 1? Of course, this will be 1. This minus will be 1 over 3 raised to the power 1. Of course, we know 3 raised to the power 1 is same as 3, which is 1 over 3. Now, what if we have 3 raised to the power minus 2? So this will be 1. This negative will be 1 over 3 raised to the power of, don't forget we have removed this minus, which is 1 over, then it's made 3 raised to the power 2, which is 1 over 9. That is how to get about negative index law. Yeah, the next law is root power law. Root power law. What does this root power law imply? This root power law implies that when you have a number, okay, in general, says when you have a number, say x, is raised to the power of it's raised to the power of half. So this will give us the square root of x. Square root of x. Of course, it's all into 1. That's root power law. Alright, let's take some examples of the root power law. Some examples of the root power law. Number 1. Of course, 9 raised to power 2 will give us square root of 9, which is 3. Then we will have square root of, let's say, 16 raised to power 2. That will give us the square root of 16, which is 4. So the next law is, the last law is the fraction index law. You see, the only difference between the root power law and fractional index law is that any number raised to the power of 1 over 2 is the same thing as saying the square root of that number. That is what this law of power, that is what root power law says. Root power law says when you have a number that is raised to the power of half, is the same thing as finding the square root of that number. That is root power law. But fraction law now is an extension to root power law, and it's telling us that there are instances where you have some numbers that are raised to the power of fraction. So how do we deal with that? And so in general, when you have a raised to power 1 over 3, so that will give us the cube root of a all into the square of 1, the numerator. The root here will be determined by the denominator of the power. Then the power outside the bracket will be determined by the number of the numerator. Now let's see what I just said now. Let's say again you have a raised to power 2 over 5. A raised to power 2 over 5. Of course, we know this will be fifth root of what? A to the power of the numerator 2. So let's say we have 2 raised to the power of, raised to the power of 3 over 4. This will give us the fourth root of 60 all into the root of 3. And of course this will be, of course we know the fourth root of 16 is 2. That will be 2 raised to the power of 3. That will give us 8. How do we get this fourth root? We look for a number that when you multiply 4 times, it will give us 16. And that will give us what? 2. So if you are not clear with that, we can let me easily run you through the process. You can easily draw your line as if you are looking for LCM or HCM. You can say 16, 2 to give you us 8, 2 we give you 4, 2 we give you 2, 2 we give you 1. 1, 2, 3, 4. So just pick one, that is the fourth root of 16. We can see that with these 8 laws that we have talked about, it becomes very easy for us to solve any indices problem. I mean any indices problem, except for some exponential function that we are going to treat after these indices. So going through the 8 laws, so far we have gone through all the 8 laws. We have taken the division law, we have taken the multiplication law, we have taken the zero index law, we have taken the negative index law, we have taken the root power law, we took the fraction index law, we have taken the product power law. I think those are the laws we have taken so far. If peradventure you could not get all these laws, I think you should go to the previous videos that we've uploaded. You will get these laws, because without having a thorough knowledge of this law, the attempting indices problem will be somehow problematic. It will be somehow cumbersome, and it will give you some problem. And that is why it's advisable you first of all have a deep knowledge and understanding of the law of indices before you begin to approach any indices problem. In our next video, we are going to go straight into solving indices problem, probably from the scratch to WAEC level, and even probably to JAMB level. Thank you very much.